Welcome to the industrial classroom. In today's video, we will learn about the conveyor belt vulcanizing machines. We know that conveyor belts can be jointed using two techniques. The first one is the hot technique and the second one is the cold technique. We have discussed about the cold technique in the previous video. You can refer to it. The hot technique we will describe in the next video. But before that, we need to learn that any conveyor belt, if jointed in the hot technique, the machine comprises of three components. Okay, the three components. The first one is the heating element or the heating unit, we can say. The second one is the pressurizing unit. And the third one is the we can say an intact unit or support unit. Whenever we come to the water bag machines, we will learn that there is also another component which we can say is as the cooling unit. But remember, this is not present everywhere. It is present in some special machineries we will discuss. Now, the conveyor belts, as we know, let me take you to the new slide. So this is an image which I have collected. Here you can see this is the conveyor belt vulcanizing machine. So how is this unit vulcanized? First, see, you can see there are two sets of machineries. This one I am painting it here. See this color. I am painting this one is the top elements or the top parts we can say. Now I am coloring with some different color. This one is the bottom part. Okay, these are the top and bottom supports. In between here you can see we will find a element or a simple box like structure here. This is the 3D part. I will explain it in detail here. Just remain here. We will study it in very much details. You will not have any doubts further. So this one is the heating unit. Okay, so what is the structure generally? Here this is the heating element. Okay, the top one, the bottom one, and here we have the supporting beams. Okay, these are the beams. Let me just draw it like this. And then in the top side we have beams, the top beams. What happens that whenever these heating elements, let me write it as HE, whenever these heating elements get warm, the belt is passed between these. This is the belt. Okay, so this is my belt, and I need to heat in this region. Let me suppose that this is my region where I want to heat. Okay, so this is my belt passing through it. Whenever I turn on the power, I see that the heating elements get warm. Okay, and there is a controller here, a setup box we can say. Wherever a control panel is there, which controls the temperature. Okay, for every heating process we need to know that there are three processes. First is the heating, that is whenever the temperature goes beyond the atmospheric temperature or the normal nominal temperature, we heat it to certain temperature so that the conveyor belt here melts. After melting, we hold it at some temperature at some fixed time. We will learn about it. This is the curing process. Okay, so why is this process? So that the molecules inside the molten belt, they integrate to some fixed molecular size. Okay, whenever there is heating process, we can say there are abnormal sizes in the structure of the molecule. To bring it to a uniform structure or homogeneous structure, we hold it for about 1 hour. This is the curing, and then we go through the cooling phase when the molecules again integrate it. Okay, so what happens? These are two pieces of rubber. I heat both of them. Now they have become molten, but they have not now joined, because here they have become molten. Okay, liquid like formation. Whenever I store them at some curing temperature, both of them start jointing and become homogeneous. Now after becoming homogeneous, we can say solute, or we can say the homogeneous mixture, then what happens, we now cool it. Now both the rubber particles, they integrate and form a single particle. This is the complete process of This is the complete process whatever we do in the hot vulcanization, right? So we have discussed here that the platens become heated, which in turn heats the rubber within it. Now what are these beams present for? What are these? These hold the these hold this structure completely firm. Within this beam, what I do the bolting. So you can see this one is one bolt, this one is another bolt, this one is a third bolt. That will bring you to the second image here. This here is the bolting. These are the beams here, right? This is a structure here. This is one component here. They are fixed by some pins. Now what I do that this is my structure. Now what I do the bolting. With bolting, I keep the top frame and the bottom frame intact. Remember, during belt jointing, we need both heat as well as pressure. Otherwise, the belt joints will form a air gap, a rubber balloon type formation. To prevent this, we need both heat and pressure. So whenever we apply pressure, the without holding these beams, there is a tendency that the top platen will remove out. Okay, so if I remove this pressure from here, okay, whenever I apply pressure, let us say that here we apply the pressure. So there is a tendency that whenever this both of them are not fixed, the pressurizing unit will remove this platen upward, this will move this platen upward, or this will not support the beams. So there will not be evenly pressure distributed. Therefore, to satisfy the need, we provide here the bolting arrangement. So these beams and the bolts, they form nothing but they are the support unit, right? Or you can say it's holding unit. So we learned about the heating unit, which consists of some platen. We learned about the pressurizing unit. Let me show an image of the pressurizing unit here. This this is a beam. Okay, this is a beam of which I got from the Thezo website. It's a very large company. Wherever the belt formation, they deal with active belt solution. Okay, so these pressurizing units, what's the structure generally? This is my beam, right? Why is this structure formation? Because here we put the bolts here. Maybe I can use some different colors so that you can understand it very easily. So let me consider this is the top beam and this is my bottom beam. Okay, these are the beams. Now here, this arrangement here, this design is provided to lock this bolt here, and there is a screw system here, right? It is a screw here. Now what happens? There are threads here. I can loosen this to bring these bolts, these heads, okay, to move these heads to the desired location. You remember that whenever there is a platen, we know that the belt size is not always uniform. It might be 18 mm, it might be 19.2 mm, it might be 21 mm, or may go down to 10 mm also. Okay, the belt sizes may vary, so we also need to vary these machine sizes, this bolt size. Okay, so these threads are given to adjust these different sizes to accompany to accommodate these sizes, right? Now within these bolts, now let me just remove these heaters here. I don't need these heaters, I don't need either this bolt. Okay, so this has been deleted. Just a minute. So now see, this is my bolting here, and within this bolting there is a pressure unit, a cylinder, and beneath the cylinder there is a plate here, right? So what is the arrangement? This is the cylinder here, and a pressurizing and a plate, and on this cylinder there are connection for the valve. Okay, whenever I connect, so you can see from this point we can insert the we can provide the hose connections to these, and there are hose connections provided in the machine also, and this pressurizes the complete unit. This is in case of hydraulic. Now before moving to the images, I have lots of images here, but before moving to the images, let me make your concept clear. See, the pressurizing unit, Pressurizing unit can consist of two types, are of two types. First, we can provide hydraulic pressure. Okay, we can provide hydraulic pressure. In second, we can provide water bag pressure using water bag. So remember, in hydraulic pressure we have beams here. Okay, this is my single beam. Let me just make it simple. And here I have multiple cylinders. Beyond beneath the cylinders, I have some plates. Okay, whenever I keep a platen beneath it and apply the pressure by using the hydraulic hose, there is an pressure distributed on this platen which applies the pressure on the belt. This is the arrangement of hydraulic pressure. Next, in case of water bag, there is a platen, and above the platen there is a bag, a jacket. Okay, you have seen the warm pressures or the hot pressures provided whenever you have an egg or something. So there is a water jacket here. What I do, whenever I require the pressure, I adjust the pressure, provide the pressure to this jacket. The jacket has water in it. The water goes until the pressure limit is reached, and as soon as the pressure is reached, for example, I need to provide 4 bar pressure, or sorry, 4 kg per centimeter square, or let me just take an example with 300 bar pressure. Okay, so what it does, whenever pressure inside the bag reaches, the pressure is provided by water. Whenever the pressure inside the bag reaches 300 bar, now this pressure is applied onto the platen beneath it. Okay, in the bottom side there is no need for pressure because it's already held by some rigid support. You are supporting the belt on some frames, right? So from the top I am applying pressure. Similarly, in this, there is the bottom plate, there is a top plate. On the top plate we always have the pressurizing unit. The pressurizing unit can consist of hydraulic pressure or the water bag pressure. Now I think that you are clear. So whenever I say here, these are the parts here, let me just have a go through these parts. Okay, maybe in this image you might understand it very easily. So just a minute. So see, what I have this. These are the platens, okay, or the heating elements. Here, this is the top platen. See the upper platen. This is the upper platen. This is the lower platen, right? Within this platen, I have the heating elements, and there is a pressure bag. Pressure bag is present here, where pressure bag is present in water bag machines. Okay, and there is a back plate. Why are these back plate given? We also say these are the pressure plate, or sorry, we say it is the pressure ply. Why? Because we have these beams. Okay, beneath these beams you have the water jacket. So you can see there is a very small contact area at this point, and these are very dangerous because whenever there is larger pressure of 300 bar, we need to ensure that these points, since these are metallic beams, okay, generally made of aluminum or some aluminum and some alloys mixed to make them lightweight as well as highly conductive, or we can say conduction of heat. Okay, so these are metallic plates. So to ensure that the pressure inside the water jacket does not burst the bag when in contact with these metallic elements, we provide a small pressure plate here or a bag plate here, so that the jacket is not in direct contact with the beams, right? Now let us go to this. This is an image which you can see here. This is the bolts. Okay, these are the bolt plates. Now this is the heating element or the platen. You can see metallic type, and these are the beams. This is the panel. Okay, in this panel what happens, for example, if you set temperature 145 degrees Celsius. Okay, remember this is for normal grade of belt. In case of UHR you might go to 160 degrees Celsius. So this is the temperature at which we heat the belt so that the rubber completely gets melted. So these are the indication lamps, and these display the temperatures. Fine. So whenever you are hitting this, for example, now my temperature is 60 degrees Celsius, ambient temperature. Okay, now I have started the machine. I have turned the switch on. After turning the switch on, the indication lamps will glow. After that, There are two indications. See, this indication lamp is for this panel, this is for second panel. Why are these panels used? For example, if I have two machines, here this is the top platen, the bottom platen. The temperature of both the platens will be displayed in different panels. Right, I have turned the machine 60 degrees Celsius, 70 degrees Celsius, and then finally it will go to 145 degrees Celsius. Okay, or 160 degrees Celsius. What you have set? I have set my temperature at 145. So the limit will also be shown in this display here. This is the display. In this display, the limit will be shown here, as well as the current temperature will be shown here. Okay, whenever there is a 145 degree temperature, the sensor has reached here 145 degree temperature. So this is the input panel, and here also we have the sensor panel attached to this. So whenever the sensor or the piezometer, okay, this is nothing but a piezometer sensor, a temperature controller. Okay, there is inside the control panel we have a temperature controller. When we have adjusted to 145, now my temperature is reached 145 degrees Celsius. What happens? It will automatically cut off the power supply to this machine. So what happens? Since the machine is cut off, now the temperature will be maintained at 145. As soon as it reaches 144 or 143, again it will provide the supply. Now the temperature will reach 145. So this is the point where the panel becomes very much important, because we know that it is controlling everything starting from heating to the curing. Okay, now, but since we have reached 145 degrees Celsius here, whenever it shut downs, the machine becomes bit cooler, 145, it again turns on the power. So now it again heat to 145 to 146. Whenever it reaches 145, it again cuts off the supply cuts off, and then again as soon as the machine becomes a bit cooler, it again restarts the machine. This is the entire process of the control panel, to shut down the electricity and to provide the reconnection. Okay, now this is the pump. Here is the image of the heat pump here, the hydraulic pump here. This pump has oil inside, it's a hydraulic oil. Okay, now the work of this hydraulic oil is to provide pressure to these cylinders we discussed, right? So this is the handle with which the pressure is provided. This is the barometer here, a pressure gauge here, which provides the pressure display. So we have learned about this hydraulic system. So this is the complete arrangement. We can increase the number of platen sets. See here, you have two sets, top and bottom. Here is the second set, top and bottom. To provide for a more longer joint adjustment or a longer length of joint, we can provide numerous number of machines here, right? So let me just show you a workshop diagram of the Thezo machine here. So here you can see that the pressure is provided to all the platens. Okay, there are various number of platens here provided, and here it is a distributed block. Let me show you an image. So this is a block. This is my incoming pressure from the pump, right? I have displayed a pump here. This is the handle, and here is my pressure gauge. So this is an incoming one. From the incoming, I can have multiple outlet units to provide the pressure to the hydraulic machines. So these are all outlet. So the naming will be 8 outcoming. Okay, or we generally say it as 4 by 4 or 2 by 2 way, 4 by 4 way. So here we have 4 outlets in each direction. So total pressurizing units which we can pressure will be total 8, right? So here we can see in this image that this is, let me just draw it a bit. So this is this here you can see this is the 4 by 4 way distributor block. Now these all provide pressure to these points. Now here this is the panel unit, okay, and here there are temperature markings, the shutting down. Whenever when I will make the video on the hot joints, I will generally share you all the processes, the heating time, everything, so no need to worry. First understand these machines, because we won't be able to understand them later, right? So the video will be very longer if we go to understand everything. In case of water, remember, this is the another thing that you need to remember. In case of water bags, here we don't have cylinders in between. So the pressurizing unit will be provided by a water jacket. Okay, on this platen, above this platen, there is a water jacket. okay, a arrangement of a water bag like structure wherever and this is the, you can say this is the tank. Okay, this unit is the tank unit. I have provided a photo here. This is the tank unit. Inside this tank unit, so see, this is the tank unit. Inside this tank unit, what? Let me show the working mechanism of the tank unit also. So how does it work? Just let me insert a new slide. We will go into the complete detail. Okay, we shouldn't leave anything. See, this is the 3D image of the tank unit. This is my water tank and it will have a lead. Okay. Now beneath the water tank, there is a frame structure which will have some wheel for better movement. Now on this support, there will be a motor here. I am drawing a motor, right? Motor with filters, everything. This motor is there and from this motor, we will have three connections, three pipes. So remember, what are the function of the pipes? The first is the pressure line. Okay, whenever there is water stored in this tank, let me take example that here there is water stored in this tank. Okay, whenever I turn on the machine, I set some fixed pressure here. Let me say here I have provided, so the pressure display will be something like this. A spring loaded pressure gauge is provided and this is a movement and a spring pressure gauge is provided here. It will have units for marking 4, 6, 10, 12, 14. Okay, so there will be marking and the small ones, the 5, 7, these small dotted lines. So this, so 4, 6, 10. So whenever I provide a spring loaded pressure at some for example, I have now started the machine and have provided 4 kg per centimeter square. Now whenever the at the beginning in the water bag there is no pressure, so the pressure is 0. Whenever I start the motion motor, now the pressure I provided is 4 kg per meter centimeter square. The motor runs. The motor runs, draws the water from this line, from this water pump, and then sends it from the pressure line to the water bag. So the water bag now gets the water, receives it, and whenever the pressure 4 kg per centimeter square is achieved, whenever this pressure is achieved, this pressure pressurizing unit will be deactivated and the power will be shut off, similar as in the control panel. Okay, so this pressurizing units gets cut off, right? Remember, now I set it as 6 kg per centimeter square. My pressure inside is 4 kg. So now I again turn on the power. Power turning on is manual and it is not automated, right? Turning off is automated. So I have turned it to, now the pressure inside the bag is 4. Now my required pressure is 6. So the motor again turns her till it reaches 6. As soon as it reaches 6, the pressurizing unit will again turn off the motor or the pump, right? So this is the total working of the pressure line. Next we have the cooling line. Remember, in case of water bag machines, okay, inside the platen, so let me draw, this is the platen, right? It looks something like a square box only. Inside it we have a heating mat. Okay, there is a mat which has coils in it and it heats the total platen. Now in case of water pressure bags only, water pressure machines only, and not in hydraulic, in this hydraulic we don't have this option. In case of water bags, we have a motion, a pipeline inserted in this, a cooling line. Okay, from there you get the input, from here you get the output. In the platen, on the in the heating element itself, we have a coil like arrangement. Okay, so this cools the machine in a very short time. So this is the biggest advantage of the water bag machine. Why are you using it? Because in case of hydraulic, the cooling time is increased by the cooling time takes generally 3 hours, but in water bag machines in 40 minutes or max to max 1 hour. So there is a 2-hour reduction of cooling time. So whenever there is less MTTR, okay, minimum time to repair, we use the water bag machines. So this is the cooling line. And then in the fourth we have the drain line. Whenever I open the drain line, what happens, the as soon as I see, I open the pressure line, the pressure is provided, the cooling line, the valve is open, the cooling is done. And whenever I open the drain line, what happens, I close all these cooling lines and pressure line, and the water gets removed from here to the tank. Okay, so these are the working of the machinery. Now let me show you some of the images here. This is the image and this is the complete setup image which I have provided. So what happens? I have turned on the panel. The panel checks the temperature, everything, and this is the water unit. It provides the pressure. This is the complete working of the vulcanizing machine. Hope you have understood it. If you have understood it, please like the video and please share with your friends. Thank you.